Hi students, welcome to virtual class of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 8th standard students. Subject is mathematics. Let me begin the class.
Dear students, I am going to give some clue about the questions in your textbook, and this video is on solutions to the chapter number 1, rational and irrational numbers. Here the first question is to show the following numbers on number line. Draw a separate number line for each example. I am not going to give you the full answer for all these questions, but something I would like to tell you. You can see that denominators in all these cases are similar. The denominators of all these rational numbers. Here it is 2. The next question it is 5. The next question it is 8. Next question is 10. And number line, you know that it will be having numbers on the right 0, 1, 2, 3, to the left of 0, minus 1, minus 2. The number of divisions between consecutive numbers is denoted by these denominators. This is the only thing you should remember while making the number line, and then you will be correct and successful in making it. Okay, I am showing you the answer. You will pause the video here and do the number line, then you will click the video further to know that how the number line is created. Okay, that is your duty. As I told you here, as the number, first question is having 2 as its denominator. The number of divisions between consecutive numbers, if I consider 0 then to 1, 1, 2, 2 division, you wrote 1. So you can easily count the number of divisions and write the or show the number on number line. No more clue and help in this regard. The last question is having 10 as its denominator. This one, fourth one. So there will be 10 divisions here. 3, 4, 5, 6, 7, 8, 9, 10. These 10 divisions will be there in consecutive numbers, and if you want to represent 13 upon 10, you will count 13 from 0 and it reaches there, and here if you are counting minus numbers, negative numbers, then you will be counting to the left. Okay, let me go ahead. Question number 2. Observe the number line and answer the following question. The number line is already given, certain questions are asked, and the questions are related to your knowledge about rational numbers on number line. The question is, which number is indicated by V, which number is indicated by 1 and 3 upon 4. Here I will just tell you an explanation. 1 and 3 upon 4. 1 is a whole number, 3 upon is a fraction. It is 1 is there, again 3 upon 4. That is the question. So you need to count from here. As it is 3 upon 4, there will be 4 divisions between consecutive unit, and it is clear here 1, 2, 3, 4, and this is 3 upon 4. This is one way of getting it. Another way of getting it is 1 and 3 upon 4 is equal to 1 into 4 plus 3, 7 upon 4, correct? If that is the case, you can simply count from here 1, 2, 3, 4, 5, 6, 7, 7 upon 4. This way also you can locate. So all these questions are such that how much you know about number line and representing rational numbers on number line, how it appears on number line, all these things are checked in this question number 2. And these two is not that difficult. Coming to the next one, compare the following numbers. When a comparison of numbers comes in the case of number line, basically you should know that 0 to the right it is positive numbers, to the left it is negative numbers. Always on a number line from left to right the value of the number increases. These 2 points you should keep in mind while answering this. That means when you go to the left it is negative number, negative 1, then it -1, then comes -2. Far from 0 to the left, the number increases, but the value decreases, because the fundamental principle of number line is that towards right increases, towards left decreases. So -1 say chota hai -2. This you should remember. So the first question is, both are negative numbers, and -7 will be naturally smaller than -2. इतना बोल के मैं सीधा 8th क्वेश्चन में जा रहा हूँ. It is given here 24/8, 9/4. You are asked to compare. You have to make the denominator same. You can convert 4 this denominator into 8 by multiplying the whole fraction by 2, both numerator and denominator. So then it becomes 18/8 and 25/8. Once it is in the form of same denominator, you only have to compare the numerator to know that which one is greater. And secondly, you should also check that whether any negative sign is given in the question. 8th question, here is a negative sign, here also there is a negative sign, both are negative. When both are negative, you know the situation. As the number increases towards the left, the value decreases. So naturally -25 will be here. In this case, here we are having 25/8 and 18/8 as the number. Under normal condition, 25/8 must be bigger, but as they both are negative numbers, we will write the opposite here. That is what is given here. Okay, so like that we should apply our common sense to solve this kind of situation. Only few points you should remember. Towards right the value increases, towards left value decreases, and in the case of negative number, the value, absolute value increases, means the real value decreases. And for solving it, you will solve it in positive format, and at last you will change the sign according to the question and get the answer. All these things are enough for you to answer this second question. Going ahead. So the first question over here is dividing 9 with 37, and as the denominator is quite bigger than the numerator, the answer will be less than 1, and that is what happens. 0.243, like that it goes, because the remainder itself is 9 here. So in that case we will write 0.243 and put a bar about it because it repeats. That is one example of conversion of rational number into what we say decimal number. Let us go ahead with some more examples are there. Let me search. The second example is dividing 18 with 42. 18 to be divided with 42. Same situation, and here you are having an answer with the remainder 18, and here is a repetition of 428571. Simply keep on doing the division. Okay, let us go ahead. Here is another example. Nine upon 14. In the case of 9 upon 14, we can see that the remainder over here is not coming out as in the previous case, like dividend or divider, but there is no zero remainder also, and there is no recurring quotient also here. So this kind of decimal numbers you will write to a particular number of decimal points. There you have to close down. Understood? There is no other way left. And here if you keep on doing, dividing 9 with 14, ultimately you will end up in a recurring number. The next one is dividing 103 with 5. You are having zero remainder. Naturally 20.6 is the answer. The next one is minus 11 upon 13. When you divide 11 with 13, that is the next one. And along with that you are having minus sign also. So that also should be taken care of. And the balance happens to be again 11. That means that also a recurring number as the answer. But what actually you have to understand is, it is possible to convert a very rational number into decimal numbers like this. Some will be a complete whole number, sometime it will be a recurring number like what you observed. इससे ज़्यादा क्लू इसमें मैं देना नहीं चाहता हूँ आपको, because this is more than sufficient for you to do the sum. Here is another kind of sum. Again representing number on number line, but the number happens to be root 2. Root 2 to be represented on number line, root 3 to be represented thereafter. Understood? How to represent root 2 on a number line? We are making use of the principle of Pythagoras in order to solve such situation. What actually we are doing is, according to Pythagoras theorem, we know that hypotenuse square is equal to sum of the squares of other two sides in a right angled triangle. This principle we are using in solving the situation here. We want root 2 on number line. Root 2 by value, if calculated, happens to be 1.414 and it is recurring, non-terminating. What we will actually do is, on a number line, from this 0, if you mark a distance of 1 unit and same distance of 1 unit through a perpendicular drawn here, this becomes the hypotenuse. Let OP be the hypotenuse. Here it is a right angle. This is 1 unit, this is 1 unit. The hypotenuse square will be equal to, according to the theorem, 1 square plus 1 square, which is equal to 1 plus 1, which is equal to 2. That means hypotenuse will be equal to root 2. So this will become this hypotenuse. If drawn from here, if perpendicular is drawn from here, and if 1 unit is this much, this will be root 2, because this is 1 unit and this is 1 unit. This length is root 2, so we can bring it over here and mark root 2. That is what is done here. Understood? Next we need root 3. So what we will do, that is a question here. We already have root 2. So we will take root 2 square, this much length, and again 1 square. Root 2 square is equal to 2, 1 square is equal to 1, and total is equal to 3, which is equal to r square. Then OR will be equal to, this is OR square, root of 3. So we can draw root 3 also in that way. That is what happened. Then how can we think about drawing root 4 is not coming in the picture, root 4 is equal to 2 only. How to draw root 5 on the number line? That is a nice question in our mind. Now we know how to draw root 2. Then we know root 3. Root 4 is equal to 2, so no need of any difficulty in drawing. Then root 5. To draw root 5, you should create an equation of in this format, where length of one side of the triangle must be equal to 2 and the other must remain at 1. So 2 square plus 1 square, which will be equal to 4 plus 1, which will be equal to 5, which is hypotenuse square. Then hypotenuse will be root 5, and that root 5, which is of hypotenuse, you will extend here to get the answer of root 5. It goes on like this. Little care and little common sense is very essential for following. Now here is a drawing of 7. So first there will be root 4, root 5, root 6, root 7. It goes like that. Understood? So this is a very important part of this lesson, because you are drawing numbers like non-recurring, non-terminating numbers on number line. It's a very important exercise. Finally, you are asked to draw root 5, root 6, root 7, anything such. You will keep on adding one unit and go ahead. In order to get root 2, we had the sides 1 square plus 1 square. Understood? In order to get root 5, we had 2 square plus 1 square. Correct? In order to get root 6, you will be having root 5 already, which you have got, plus 1 square, which is equal to 5 plus 1, 6. In order to get 7 square, you have already got root 6 square plus 1 square, which is equal to 6 plus 1. Understood? So this must be very clear to you. Little care is required while doing it. You can serially do this, and you should do it. वापस 9th में आ रहे, थोड़ा और factors add करके. But before that, you should be very clear about how to represent these numbers on a number line. Okay. These all are from your textbook. It will help you to understand. You can watch the video, stop the video, pause the video, and go to your textbook. कैसे भी कुछ भी करके, you have to complete the exercise so that you will be very comfortable with the number line and rational numbers. Thank you.
Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.